We will open up a new standard millimeter part. Our sketch will be the XY plane. The first thing that we'll do is we'll add a vertical line and then convert that to a center line to use as a piece of reference geometry. Create a line of arbitrary length coincident with the y-axis. Right-click the line and choose Center Line. Using the Line tool, we will sketch an initial outline of our shape. Now that my general shape is drawn, I can dimension it so that it takes the correct size. What we'll do first is known as a diameter dimension. Click the Dimension tool, click the rightmost edge of the sketch, click the center line, move your mouse to the left and notice there's a diameter symbol with diameter 157 or whatever yours may show. Click that. Change that diameter dimension to 111 millimeters. Press OK. Next, set the thinnest part of your sketch to be dimension 1. We'll now do another diameter dimension from this edge. So click the edge, the center line, move it. That dimension is 95 millimeters. Next, we'll dimension the bottom edges. 86. I messed that one up. 81. Now we'll start putting in some of the vertical dimensions. 6. 8.5, overall height 70.5, I just got a driven dimension. There's an error. At this point, your sketch is probably not fully defined yet. Mine is missing a dimension between the top of the center line and the top of the sketch, which is a non-critical dimension. So I will click Done, finish my sketch, and then I want to revolve my sketch around that center line. Revolve. I want a full revolution. Click OK. And now I want to make sure that I'm creating the right part. So I'm going to check my eye properties to see what the weight is. I want the material to be cast steel. Steel, cast. And I want to check that my mass is 0.557 kilograms with a volume of approximately 70,946.037 cubic millimeters. I'll click OK. I've created the part correctly. Next, you'll want to do a new sketch on this face right here. So click that face, new sketch. Now we want to turn on the visibility of our x-axis. So in our tree, we'll select the drop down for origin, hover over x-axis, right-click, and select Visibility. It's a little bit darker. Now we'll rotate 90 degrees, and we're ready to begin our sketch. Our sketch is going to use a piece of pre-existing geometry as a reference, so we'll want to project the geometry. It's one of the circles that you can see by hovering over your mouse and seeing it turn white. So click Project Geometry and hover until you get this line. Click it. To make sure that you've selected the correct line, dimension it and make sure it's 97 millimeters. Mine says 95, so I've selected the wrong one. So undo, project geometry. That should be it. 97. It's a driven dimension because it already exists. It's already locked in place, so that's fine. But now I know that I've selected the right circle. We will now place a center line beginning at the origin and going vertically to the outside of the part. Select Line Tool, snap to the origin, click, click, right-click, select OK, right-click, change that to a center line. Notice the dashes in between it. We will now create a new sketch on this surface. New sketch. We're going to go to our tree under the origin folder and make the x-axis visible. Right-click, select Visibility. We're going to use our line tool, create a line from the origin vertically through the part. Click, right-click, select OK. Right-click the line you just made and turn it into a center line. Notice the dashes in between the longer portions of the center line. What we'll do now is we'll use the Arc Center Point tool to create a 120-degree arc above our part. Arc, Arc plus Center Point. Snap to that center line that you drew. Click. 6.5 millimeters, press Tab, click, type 120 degrees, Tab, press Enter, click OK. Notice our arc is now outside of our part. We'll use the Project Geometry tool to select a specific piece of existing geometry on this part. Never mind, we already selected that projected geometry earlier. We'll now use our line tool, snap to the end point of the arc to the projected geometry, go to the other end of the arc, click, go to the projected geometry, click OK, right click, select OK. We need to make sure we have a tangent relationship between the end of this arc and this line segment, so we'll use the tangent constraint. Click that, click the arc, then this line. It moves a little bit. Click OK. We'll now use the symmetric constraint. Choose this branch, then this branch. I think my computer froze. Yes, it did. I've selected that branch, then I select the center line, and it's now symmetric about that center line. We're missing one dimension in between the center of that center point arc, which should show up as a small white square. We click that. We click the origin. That dimension should be 58.5 millimeters. Click OK. Finish the sketch. We want to extrude that profile 8 millimeters. Extrude, select the profile. We want to change the direction of the extrusion, so we'll choose direction 2. By default, my extrusion turned into a cut here. I don't know if yours will, but I have to change this to an additive process instead of a subtractive process. I click OK. and now I have one of these little wings coming off of my part. I'm going to now use the eye properties to check my mass and my volume. Eye properties, physical, update. I'm looking for a mass of 0.567 kilograms and a volume of approximately 72,280.371 cubic millimeters. The decimal should be pretty close to mine. It might not be exact. We will now create a threaded hole on that wing that we just created. So we will click the hole tool, and under placement we're going to change that from linear to concentric. We now have to select the plane. The plane that we're going to click on is the face of that wing. We click. Our concentric reference is that arc. So we go and we zoom in and we click the edge of the arc, and it puts the hole that we want to create in the exact center of the arc. Now this is a threaded hole, M6 by 1, that's a metric. So we'll select the threaded hole command. Change from ANSI unified screw to ANSI metric M profile. Change the size to 6. This is a through hole, so change the termination from distance to through all. Click OK. And now we have a threaded hole through that wing. We're now going to make a circular pattern that patterns both the hole and the wing around the outer circumference for a total of 3 times. So we'll select circular pattern. The features that we want to pattern are the wing and the threaded hole. So click both of those. They should turn blue. The rotation axis is the outer circumference. We click that. We want 3 occurrences. Click OK. And we'll check to see that there are now 3. At this point we should check our mass in the Eye Properties tab. We should have a mass of 0.585 kilograms with a volume of 74,493.315 cubic millimeters. Close, save. We are now going to cut a groove cut on the surface that has the 3 wings. So we'll start a new sketch on that surface. We will draw 2 circles. Start at the center of the revolution. Its diameter should be 100 millimeters. Draw another circle that begins at the same center, and it is 108 millimeters in diameter. Finish your sketch. We're going to cut that circular groove 3 millimeters deep. Extrude. Select the groove. Direction 2, change it to a cut, distance of 3 millimeters, click OK. We will check our mass and volume in the Eye Properties after this feature has been added. Physical. We should have a mass of 0.554 kilograms with a volume of 70,572.608 cubic millimeters. We are now going to add the second style of wing, but it's on a different face. Rotate your part so that you can select this face. Start a sketch on that face. We want to turn on the visibility of our Z-axis. So we right-click, Z-axis, select visibility, rotate our model. Our new wing is going to go through the Z-axis. We'll first want to create a center line from the origin above our part as we did before. Convert that to a center line. We will next want to select the same projected geometry as we did before, the 97 diameter circle. So we can select Project Geometry, hover our mouse, and it's one of these circles. I believe it's this one, but we'll check with our dimensioning tool. 100, that is not the correct one. Undo. Project geometry again. Click. Dimension. 97, that's the correct one. Cancel the dimensioning. We will use the center point arc tool as we did before. Snapping to that center line, we click. 12.5 millimeters, tab, and click. Type in 110 degrees, press tab, enter, right click and select OK. Right now my arc is a little bit crooked, but once I add my lines and my constraints it should right itself. So we'll use the line tool, select the end point of the arc and the projected circle. Do that again with the other side of the arc. Right click and select OK. We're now going to add two tangent constraints. Tangent, the arc and the right branch, the arc and the left branch. We now want to add a symmetric constraint if it'll let us. Symmetric, right branch, left branch, center line. The final dimension is a dimension of 60 millimeters from the center of that arc to the origin. Right click and select OK. Finish your sketch. We're now going to extrude that second style of wing. It's facing the wrong direction right now. Change to an extrusion from a cut. The distance is 12.5 millimeters. We click OK. When I checked my mass just a minute ago, it was wrong, and I had to figure out why. This dimension of 12.5 here should be 12. So go back into your sketch, double click that dimension, change it from 12.5 to 12, finish your sketch, check the mass and the volume now. You should be at 0.607 kilograms with a volume of 77,368.848 cubic millimeters. Close. We now need a hole on that second style of wing. It's a diameter 10 through hole. So we'll select the hole command. We want our placement to be concentric with the arc. The plane we select is that face. The concentric reference is the edge of the arc, and we have to change, if we might still be in threaded from the last hole we made, we need to change to a simple hole. The diameter is 10.5, not 10, and it is a through all hole, so we click OK. I made a mistake earlier when I said through hole. If you'll notice, a through hole actually cuts through a portion of the model, which we don't want. So we'll go to our hole 2, or whatever it's labeled on your feature tree, right click, select edit feature. Instead of our termination being through all, change that to 2. Select the bottom edge, and it'll make the hole stop right when the edge begins. It'll be a through hole as we expect it to be. Click OK. We'll now check the mass and the volume. The mass should be 0.599 kilograms. The volume should be 76,286.471 cubic millimeters. Click Close. Save your work. We want that second style of wing and hole to be mirrored. We want it to be on the direct opposite side of our part as well. So the question becomes, what plane do we mirror it across? If we select our origin folder and hover over the different planes, you can see them show up. We are going to want to select the XY plane. Turn on the visibility of the XY plane. Now you can see it. We'll select the mirror command. The features that we want to mirror are the second style of wing and the 10.5 diameter through hole. So click both of those. They must turn blue. The mirror plane is the XY plane that we selected earlier. And we click OK. And our feature has been mirrored. We'll want to check our mass and our volume now in the eye properties. Physical. Mass should be 0.644 kilograms. The volume should be 82,000.335 cubic millimeters. Close. We will now create a second groove cut on the surface with the larger wings. We can turn off the visibility of our XY plane at this point. We're going to select this surface to work on, new sketch. We want to draw two circles for the groove as we did before. The center of the circle will be the center of our part. The first diameter is 90.4 millimeters. The second circle has a diameter of 102.2 millimeters. Right click, select OK. Finish the sketch. We're going to cut that profile. Our cutting depth is 4.7 millimeters. Click OK. Your new mass can be checked in the Eye Properties tab. It should be 0.578 kilograms. The volume should be 73,611.029 millimeters cubed. Close. We are now going to create a reference plane that we will use to sketch our rectangular extruded portion of our part. We'll turn on the visibility of our YZ plane. Right click, select visibility. You can now see the YZ plane is visible. The plane we create is going to be offset from this plane, so we'll choose plane, offset from plane, select the YZ plane, and our new plane should be 66.8 millimeters away from the YZ plane. Select OK. We now have this other plane that's outside of our part, and we will sketch from that plane. We're now going to rotate our part a little bit, like so. We'll start a new sketch on that work plane. We can turn off the visibility of the YZ plane. We no longer need it. But we will turn on visibility of our Y-axis. In our sketch, we'll select Project Geometry. We'll select the Project Geometry, select the Y-axis, and the Y-axis now becomes a selectable piece of sketch in this particular sketch. We will now project another piece of geometry, that is the bottom edge of our part. That edge is now selectable within our sketch. Right click, select OK. We now want to make a rectangle that is 45 units tall and 54 units wide. So we'll select rectangle, 54 by 45. Press enter. We want to dimension that rectangle. We want the bottom edge of it to be 4 millimeters away from our projected geometry. And we also want this rectangle to be symmetric about our y-axis. So we'll use the symmetric constraint, which is up here. We'll choose the right edge of the rectangle, the left edge of the rectangle, and the y-axis. And now it's fully constrained. My initial sketch was incorrect. I had my directions flipped around. It should be 45 units tall, 54 units wide. What we'll do now is we'll extrude that rectangle until it stops at the circular edge. So we'll click Extrude, change the direction of the extrusion. Instead of distance, we'll say to next, And notice that the extrusion stops automatically at whatever surface it happens to come in contact with first. Click OK. We can turn off the visibility of the work plane we created. We'll want to check the mass and volume after this extrusion. We should have 0.963 kilograms as our mass, 122,698.543 cubic millimeters. Save your work. We now want to create the counterbore hole through this rectangular surface here. So we will start a new sketch on that particular surface. We'll use the point tool to create a random point for use as reference geometry later. We'll hover over what appears to be the center of the rectangle. We'll click and we'll force it to be in the center using dimensions. Since our circle is 54 units wide, we know that our point should be 27 millimeters from the left edge. So we'll confirm that. 27 is good. Since our rectangle is 45 units tall, we'll want this point to be 22.5 millimeters from the top edge. And it's not, so we'll force that. We'll click OK. Now this point is in the direct center of our rectangle. Finish the sketch. Use our hole tool. And our placement will now be from a sketch, the sketch we just created. The center is that point that we drew. This is a diameter 30 through hole to the center. It's counterbored at a diameter of 36 at a counterbore depth of 2 millimeters. So we'll change to counterbore. 36 is the counterbore diameter. The hole diameter is 30. The counterbore depth is 2. Our termination will not be through all. It will be 2. And we want our hole to end on this inner surface. Click OK. Notice the counterbore, and notice that it does not go all the way through our part. It does not go through the other side, in fact. At this point, we should check our mass and volume. The mass should be 0.848 kilograms. The volume should be 108,010.260 millimeters cubed. Close. Save your work. We will now add 4 radius 4 fillets to this rectangular extrusion. Fillet. Change the radius to 4. We want to select this corner, this corner, this corner, this corner. Select OK. Notice the edges are now rounded. We'll check the mass. Our mass should be 0.846 kilograms. The volume should be 107,757.450 cubic millimeters. Click Close. We'll now create a sketch to determine the placement of the 4 countersunk holes that are coming next. Our sketch face will be this face, New Sketch. Use the Project Geometry tool to select the fillets. Notice that the centers of the fillets show up automatically, as do the arcs. Finish your sketch. We'll finish our sketch. Choose the hole command. We want this to be a countersunk hole, so we select countersink. This is going to be a threaded hole, so we choose tapped hole, ANSI metric M profile, size 6. Size 6, 90-degree countersink, depth of 10 millimeters. Make sure that the termination is set to distance, and make sure that your hole profile looks like mine. Once it does, click the centers of each fillet automatically, and you get the 4 holes. Click OK. Check your mass. Your mass should be 0.840 kilograms. The volume should be 106,956.675 cubic millimeters. Close. Save your work. Next, we want to add a chamfer to this top cylindrical edge. So we'll choose chamfer. We want it to be a 2 distance chamfer. We want it to be 1 millimeter by 1.5 millimeters. Select this edge, click OK, check the mass. Your mass should be 0.838 kilograms. The volume should be 106,755.613 cubic millimeters. Click Close. We want to add a couple of fillets. The large wings have a radius 2 fillet. Click OK. The smaller wings have radius 4.5 fillet. Change the radius to 4.5. OK. And now we'll check the mass one last time. Our final mass should be 0.842 kilograms. Our final volume should be 107,230.691 cubic millimeters. Click Close. Save your work.